Yeah, hey, we have some time for questions here, and as those questions are coming in, let me just real quick go over one reminder here with everybody. Just a second here. For those of you looking to take your quiz, if you're watching this live, you'll get your CEUs simply by just watching this session and then filling out that survey that pops up here at the end. And then for those of you watching this on demand, just make sure to take that 10-question quiz. And you can head down to the YouTube logo down there under the video, and then go ahead and click Show More on the left there, and on the right you can find that quiz link. And yeah, a lot of questions coming in, and as we're going to get to those as those are coming in, again, a huge thanks to all of our members, our volunteers, our board of directors, everyone who allows us to do what we do, and a huge thanks to our top tier sponsors, Panasonic, T-Stud, Mitsubishi Electric, and Rheem as well, for making high performance products that help you make better buildings. So going back to the I believe it's the blown in, and Mark, correct me if I'm wrong, but the question here was specifically to settling on the blown in, and whether that is a concern at all.
Yeah, that's a really great question, and the idea of settling could actually be considered across the board for both cast in place as well as spray applied hempcrete. However, you're actually going to see that a little less with spray applied. We're using essentially a 375 cubic foot per minute compressor. So that is a very large scale compressor to spray apply this material, and that compacts it to a really kind of dense material that is not going to slump it's going to slump a lot less than your actual cast in place method, which you could see settling occur during the curing process of probably over a 2-story wall, about a 1/4 inch at most. So it's not a significant amount, but it's going to be more of a concern with actually cast in place as opposed to spray applied.
Well, I'll get to this one a little bit. But what about the embodied energy and/or embodied carbon? You showed us that machine sort of during the process, and maybe relatively compared to all insulations that have to be manufactured and processed after the raw materials are extracted. I mean, what do you have any comments or insight as to whether that's more or less itself?
That's a really great question, and I wish I actually had included it in here. I have a graph that was created by the Endeavour Center in Canada that shows the embodied carbon footprints of various various insulation materials, with the most carbon intensive being spray foam, expanded, I believe XPS spray foam. That chart does a great job at showing just the impact that these different materials have. Fiberglass does have an embodied carbon footprint with it, but then you look down at the very bottom of the chart. Hempcrete and hemp wool are actually storing carbon dioxide. If it's something that we could put up as a resource after, I would love to share that, because I think it's a fantastic resource when you're trying to evaluate your different insulation products from an embodied carbon perspective.
Yeah, definitely. Let's make a note to send that out. That'd be great. Getting into some comparisons between hempcrete and wool. I mean, is there any difference in the mold resistance between the two, or is it fairly negligible?
They are actually both mold resistant materials. We've done some experiments here in our innovation lab of essentially saturating hemp wool panels next to fiberglass, and it's amazing because the fiber itself is so absorbent. it wicks that moisture up, it holds that moisture, just like wool. You know, the reason that we wear wool socks when we're skiing, it's so that it holds that moisture, it doesn't make you cold, and it releases that moisture. The fiber of the hemp stalk is really great at doing that, but also the hemp core has a similar property as well. So they are comparable in their mold resistance. I would say, however, in a conventional assembly where you'd be applying hemp wool, you're more likely to run into mold issues just because of the way our conventional assemblies sometimes can lead to that if details are not well executed. A hempcrete assembly is going to do even more work in regulating the sort of thermal comfort and the moisture in the air than hemp wool would. So in that sense, hempcrete is superior, but is much more of a systematic approach than hemp wool is.
So on that note, would you say that the strategy to the rigid hemp wool, that you're really trying to get a permeable system as well to prevent those kinds of mold and moisture issues?
Yeah, so that's a really great question, and I think there's so many cool, interesting, unique sort of building technologies that are coming out right now. I love sort of the advent of you know, more breathable vapor barriers, using sort of more rigid insulation boards that are made from wood pulp on the outside. But I think the idea here is to not trap moisture, and so hemp wool does a good job at mitigating moisture, but the best situation and scenario for hemp wool to be incorporated in is a situation that is fully considering a vapor permeable envelope. It's not to be said it couldn't just be put up against old-fashioned OSB or plywood with a tie-back vapor barrier on it, but there are ways of making it a more sort of holistic approach, just by way of substituting some products. For instance, you could substitute, say, plywood with magnesium oxide board or another sort of breathable yet structural substrate.
Do you, or getting into the that notching you had mentioned, I think the question here is wiring notch versus cut slot for wiring. Does that make any sense to you?
It sure does. And that portion in the video, does not show the best example of notching around wiring. That video was like a very last minute add-on for our videographer, and so a better, more superior means would have just been taking the sort of a cutting wheel and just running it across and creating a slot for that wire to kind of notch around, but it had been sort of like cut off on an angle, which takes out a little bit of the insulation. So I do sort of regret showing that example to a certain extent, because it would be a more superior means of insulating to just cut a slot and seat that wire into the panel. But with that being said, I think that was just one example that this house in particular was very complex, and there was a lot of sort of sophisticated notching that had to be done. And overall, like when you're taking out material from your panel, we were always placing it behind the material. So for instance, if there was a pipe and there was space behind the pipe, we would actually take cutoffs and stuff it behind the pipe to maintain continuity of insulation.
Great, thank you. So when you showed the video of putting the insulation, the rigid hemp into the roofing, I think all of us here in cold weather climates were like, oh, R20 in our attic, that's not going to happen. So yeah, I suspect it was in a warmer place, or I guess our attendees' question is, were you potentially layering on more layers to get above R20 for a roofing application?
The primary two products that are kind of the go-to here are the R13 and R20, but we also have a 7.5 inch, it's R28. And generally that can be used with the other sizes to build up layers. So you can get your preferred performance. Unfortunately, and not my decision or call to make on this particular project, but a contractor had come through and sprayed a layer of spray foam, which actually in the photo that, if it's still up on the thank you slide, you can see a little bit of spray foam and overspray on the lid there. And so essentially we had spray foam on the roof substrate. The wiring sat in between the spray foam and then the inserted bat. So it kind of created a highway for all of this wiring that was up there and elevated the R value. So you do see us putting in R20, but it was meeting code requirements in LA with the addition of that spray foam. If you did want to go just a pure approach of using hemp wool, you can absolutely stack and combine various depths to meet your energy requirement needs.
Great, thanks. So let's talk about off-gassing and emissions of hemp on the site. And maybe I'll start first with something that I had heard about, was that there are potentially a lot of people, or could be a lot of people, who are allergic to hemp. I have a lot of plant-based allergies, so it's something I think about. I don't know if I have that one, but I saw one side where you were mentioning, at least maybe on the rigid one with the wool, that it was hypoallergenic. But can you speak a little bit too about concerns with allergies, and then I guess going off of that, any other types of VOC emissions that could come into the house from these products?
Yeah, so I'll touch on the VOCs first, and similarly to comparable products, and one for instance is Havelock wool. This material is actually proven to essentially trap VOCs, mitigate them, kind of filter them, and so it does actually help reduce VOCs in the home. And I would say that the question of allergy resistance is a little bit more complicated. However, all of this would be encapsulated in your wall system, and perhaps I'd be more concerned about the VOCs and off-gassing from other materials in the home, as well as the toxicity of more conventional materials. So bar none, it's a healthier material across the board than what we're able to use conventionally. You don't need to wear gloves. It's really non-abrasive. Fiberglass is carcinogenic when it's respirated into the lungs. It's a cancer-causing material. I rather have a plant-based material in my walls, but it's difficult for me to answer. If it's not going to work for everybody based on an allergy. We haven't run into that problem at all yet, but definitely something to consider and keep in mind. So I do appreciate bringing that to our attention. But overall, I think the conclusion is that it's a healthier, less toxic building material. And to be honest, a lot of conventional building materials have their trade-offs, and potentially an allergy trade-off is it's not a great thing, but it's not, it's, I think, negligible relative to toxicity levels of others.
So on the air quality portion, do you know if any hemp products or plan to pursue the Green Guard certification just to validate that?
That's a really great question. I was just at Green Build not that long ago, a few months ago, and became, versed in just the importance of these sort of certification programs, and it's something that we are looking to pursue. We just have not had the bandwidth or the financial capacity to do so yet, but we would like to have a declare label on our product, get Green Guard certified, and incorporate into some of those systems to validate some of these claims.
Great, thanks for taking that one. So on the rigid hemp, besides interior, can this be used either as an above grade or below grade exterior insulation as well?
I would not recommend it as a below grade material, certainly above grade without issue. If you were looking to do sort of like a kind of hybridized construction method with continuous insulation on the outside, I think it would be possible to essentially attach it on the outboard side of your studs for continuous insulation, but you would want to have some vapor barrier and rain screen detail that is sort of beyond something that we've worked on, but I think it could be possible.
So someone's here mentioning the spray hempcrete with shipping containers. Can you speak to any concerns about, I mean, what I would envision this hitting up against some kind of metal or steel?
Yeah, absolutely. Hempcrete, by way of the limestone, the calcium carbonate, is a caustic material that interacts with metal. A general rule of thumb, and to be honest, a complicating rule of thumb for integrating hempcrete into existing structures as well as new structures is that any ferrous metal that will be in contact with hempcrete should be galvanized or powder coated. So every nail that was used on our building projects that hempcrete is incorporated in is galvanized. Any metal that is a ferrous metal that is non-galvanized is ultimately treated. One of the best benefits of hempcrete as a whole is its vapor permeable nature. And so when you are putting it against a non-breathable substrate, such as metal, you are kind of eliminating one of the more significant benefits of the material. And it's not to say that there aren't other benefits, but another challenge with something like that, and again, not impossible by any means, but you would have to have some sort of substructure. So the hempcrete itself is a non-structural material, and it wants to grab onto something. It wants to have sort of an embedded lattice or structure that it can wrap around. And so if you were interested in retrofitting a shipping container or say a metal-sided warehouse or barn or something of the sort, you would need to incorporate some sort of lattice structure. The photo that we had up there didn't actually show on some other elements of the building that we had incorporated a galvanized lath. And I'd encourage you to think about this lath as something that would be laid in a slab on grade concrete foundation. So wide gauge, maybe like 4 to 6 inches for each square. But that essentially is like the backbone of the hempcrete. It wants something to wrap around. So you would have some design details to consider if you were trying to retrofit a metal-based structure.
Hey, great, thanks. So you kind of alluded to this a little bit with mentioning several times the use of prefabricated walls. But given the sort of labor shortages we have going on now, and you mentioning how labor intense something like this is, and then also giving the growing interest in modular housing, do you see maybe something like Hempcrete taking off easier within the modular housing industry?
I would love to say yes, but the prohibiting element there is the overall weight of hempcrete. Hempcrete, when dry, is about 17 pounds per cubic foot. For most common binders, we use a formula that gets us to around 12 to 13 pounds per cubic foot when dry, but that's going to be significantly heavier than, unfortunately, a styrofoam panel. And so while I do see the potential for more panelized hempcrete buildings to be built, I think shipping really needs to be considered, because that's a factor that's going to drive your cost way up. I mean, these panels are not light by any means. Certainly possible, but I would personally like to see hemp wool in more prefabricated elements, because it matches the, if not is not lighter than, but matches the weight of conventionally used products, which I think is a really big consideration for companies that are specializing in prefabbed elements.
Great. And the last question here before we head out, any thoughts on hempcrete replacing things like sidewalks, retaining walls, pavers for garden paths?
Yeah, so I think as it stands now, hempcrete is not a suitable replacement for those, just given that it's an above grade material and ground contact, perpetual exposure to moisture ultimately would not be a good thing for hempcrete. It also lacks, in general, the compressive strength of concrete. So hempcrete is not a one-to-one replacement for concrete. But with that being said, there has been some interesting research and some work done on incorporating elements of the plant itself into conventional concrete. So for instance, taking the long fibers, which the hemp wool is comprised of, embedding them into concrete to reduce the amount of rebar used, because rebar has a huge footprint, high cost, and so using the natural fibers of the hemp plant to strengthen concrete is a way that I could see potentially like a next generation hempcrete product being able to be used for sidewalks, driveways, pavers, etc.
All right, great. Well, we are at our time. Mattie and I really appreciate you coming in and doing this last minute for your colleague. Mattie Mead is the co-founder, CEO of Hempitecture. Mattie, if people want to reach out, learn more, get involved with the use of hemp products, hopefully for their projects, where can they reach you or go somewhere to find out how to learn more?
Yeah, I can be reached directly at Mattie, M-A-T-T-I-E, at hempitecture.com. I would love to chat with any and all of you about how to incorporate these products into your projects that you have going on. And just real briefly, we have a Hempcrete Contractor training program at our location in Idaho. We are working to share the trade knowledge and experience that we've gathered for people who are wondering where to start with building with hemp-based composites. So we have a course that we train people from all over the United States, architects, contractors, people that want to get involved. We also are on the web at www.hempitecture.com. And in the not so distant future, we're actually coming out with an entirely new website, which is really exciting. And I'd encourage you to stay on the lookout for that. It will much heavily focus more on our hemp wool product line, as well as our work with Hempcrete. So please don't be a stranger and feel free to reach out, and looking forward to meeting you and entertaining your questions.
All right, great. Thanks again, Mattie. Take care, everyone. Have a good rest of your week.
Thank you. Bye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.